Good morning. Today we are going to cover three topics which are stationary points, maximum point and minimum point. Okay. So let's start with stationary point. For that, let's consider a curve. In this curve, we are going to divide this curve into several parts. If you see the left side of this point, you can find the function is increasing, so that you can understand the gradient is positive. The function is increasing when the gradient is positive. And when we consider this part till here you can understand the function is decreasing when x is increasing. X is increasing, x is always increasing, but function is decreasing. So in such case we can say dy by dx is less than 0, which is a decreasing function. And the right side of this point, this portion, again function is increasing. There we can conclude dy by dx greater than 0, isn't it? Here we need to discuss about these 2 points. When you think about these 2 points, if I draw a tangent through this point, you can see the tangent is horizontal. Even here also, if you draw a tangent through that point, the tangent will always be horizontal. And you know that the gradient of a horizontal line is 0. Gradient of a horizontal line is 0. That means gradient of this tangent is 0. That implies dy by dx is 0. That means at this point the derivative dy by dx is 0. Similarly, at this point also dy by dx is 0. Those points where the gradient is 0 can be called as stationary point. So what is a stationary point? It is a point in which the gradient is 0. It's a point in which the gradient is 0. You know, gradient is derivative dy by dx. So if you find dy by dx is 0, we can call that point as a stationary point. It is also known as a turning point. What? Turning point. Stationary point is also named as a turning point because this is the point which turns the curve from increasing to decreasing, or decreasing to increasing, or increasing to increasing, or decreasing to decreasing. Okay. Now if you consider these 2 curves, when you consider this curve, you can find here this is the stationary point where dy by dx is 0. And when you find here, you can understand in this region dy by dx is positive. Here in this region dy by dx is 0, and here dy by dx is negative. So you can identify here, suppose this is stationary point. The left side of stationary point, it is positive, means increasing, and on stationary point it is 0. What is 0? Dy by dx. We are discussing about dy by dx. And in the right side of stationary point, it is decreasing, means negative. So positive, 0, negative. If you get a concept like this, you can say this point as a maximum point. So a stationary point is named as a maximum point if the term dy by dx in the left side of stationary point is positive and in the right side it is negative. Okay, even it's very simple. You see the point here, you see the curve here, where the point, this is the maximum point of the curve, nothing else, isn't it? This is the maximum point of the curve, where here we can find this is the minimum point of the curve. So those points are named as maximum point or minimum point. Okay, and to check whether the point is maximum or minimum, that is considered as the nature of stationary point. There will be an important question to find the nature of stationary point. So in such cases we have to show this, how to find the nature of stationary point. Okay, so in case of this curve, this is the stationary point. Here you can find dy by dx is 0. In this case, dy by dx is negative because it is decreasing, and here dy by dx is positive as it is increasing. So here the stationary point dy by dx is 0, and in the left side of stationary point it is negative and the right side it is positive. So the curve comes like this. So if we get this condition, we can call the stationary point as a minimum point. Okay, so now we discussed two types of stationary points. One is maximum point and the second one is minimum point. Now the third type of stationary point is stationary points of inflection. Stationary points of inflection. So in case of maximum point, if the stationary point is maximum, there you got an idea, there should be an increase, 0, then decrease. And in case of minimum point, there the idea was first there is a decreasing function, then 0, then increasing function. If you get a function like this, for example, suppose this is the stationary point where dy by dx is 0. See, the left side of stationary point is increasing. Left side is increasing. And here it is 0. And what about the right side of stationary point? Still it is increasing. So increasing, 0, increasing. Or if we get a function like this, where this is the stationary point, dy by dx is 0. When you see the left side of stationary point, here it is decreasing. What about the right side? Here also it is decreasing. So if you get stationary point in this concept, like increasing, 0, again increasing, or decreasing, 0, again decreasing. If you get the concepts in this format, we call such stationary points as stationary points of inflection. Question. Find the coordinates of the stationary points on the curve y is equal to x cube minus 12x plus 5 and determine the nature of the stationary points, and also sketch the graph. So in this question you need three answers. The first one is coordinates of the stationary points. That means x and y coordinates we have to find out. And the second one is nature of the stationary points. That means we have to find out whether the stationary points are maximum or minimum or points of inflection, and third one is sketch the graph. Okay, so let's see how to do this problem. Let us consider the equation y is equal to x cube minus 12x plus 5. Here, as we require the nature of the stationary points, so here we have stationary points, maybe one or two stationary points. As the equation is a cubical equation, we will be having two stationary points, and we know at stationary point dy by dx is equal to 0. Yes, so that is the concept we are going to use here. Dy by dx is equal to 0. So let's find the derivative of y. So we get dy by dx is equal to 3x squared minus 12. And as the point is stationary, we get dy by dx is 0. At stationary point, we get dy by dx is 0. So that gives us 3x square minus 12 is 0. That is 3x square is 12, or x square is 12 by 3, 4. So x is square root of 4, which is equal to plus 2 or minus 2. So how many values we are getting here? Yes, two values. X is 2 and x is minus 2. That is nothing but the x coordinate of one stationary point is 2 and the other stationary point is minus 2. Now our task is to find out the y coordinate. When x is plus 2, we find y as 2 cubed minus 12 into 2 plus 5. There we get y as, what we get, 8 plus 5, 13, 13 minus 24, minus 11. So this stationary point will be 2 minus 11, and when x equals minus 2, we get y as minus 2 cubed minus 12 into minus 2 plus 5, which is equal to 21. Okay, therefore the stationary points are 2 minus 11 and minus 2, 21. So remember, to find the stationary point, we are using only one concept, which is the derivative is 0. Now the second part of the question is to find the nature of the stationary point. So let's take the first stationary point, which is 2 minus 11. Okay, now here what we are going to do is, suppose this is the first stationary point, 2, this stationary point. Let's mark the number 2 on the number line. Now this point makes two sides. One is left side and the other one is right side. Okay, one is left side and the other is right side. Okay, take a convenient point from the left side. I'm taking a convenient point as 0. It's our wish, we can take any point. Take a convenient point from the left side, which is 0, and take another convenient point from the right side. What we will take? Any point we can take. Okay, let me take 5. So we have to take 2 points. One is from the left side of the stationary point and the other is from the right side. We are using only x coordinate. Okay, No use of y coordinate. Now substitute these 3 points in the stationary point. Sorry, substitute these 3 points in the derivative of y. Substitute them in the derivative of y. Okay, and you know derivative of y we already found in the previous question as 3x square minus 12. Now if you substitute here x as 0, so I'll do here so that we can draw here easily. In dy by dx, if you substitute x as 0, we get dy by dx as 0 minus 12, which is negative. That means this point is giving us negative value. When you substitute x as 2, we get 3 into 2 square, that is 12 minus 12, 0. That's already understood. And when you substitute x as 5, we get 3 into 5 square, that is 75 minus 12, which is a positive value. We don't want that value. This is just a rough work. So x is equal to 0 gives us negative value, x equal to 2 gives us 0, and x is equal to 5 gives us positive value. Isn't it? That means x is equal to 0 negative, which is decreasing function. X equal to 2, 0, which is horizontal. And x is equal to 5, which is positive. Positive means dy by dx is positive. This is the concept. Dy by dx is greater than 0. That is increasing function. So you see how the curve was formed here in this way. So in this way, what will be the stationary point here? It will be minimum point, no? So 2 minus 1 is minus 11 is minimum point. So what is 2 minus 11? It is minimum point. Similarly, we have to find out the nature of the stationary point minus 221. For that, let us take the derivative, and the stationary point is minus 221. Its x coordinate is minus 2. So we will take 3 points. One is minus 2. Take a point from the left side and also one from the right side. Left side means smaller than minus 2. I'm taking minus 3. Okay, that's enough. Any point we can take. And right side, let me take 0. Any point. Okay. Now when you substitute x is equal to minus 3 in dy by dx, we get 3 of minus 3 square minus 12, which is 27 minus 12, 15. It's a positive value. And minus 2 is the stationary point that gives 0. And when x is 0, we get 3 into 0 square minus 12, which is minus 12. It's a negative value. So we get positive, 0, negative. See the formation of graph. So that this will be the stationary point. You can understand that is a maximum point. That means minus 2, 21 is maximum. Minus 2, 21 is maximum, and 2 minus 11 is minimum. Now let us draw the graph of this. To draw the graph of this, we are not going to use any graph sheet. We are going to draw it on plain sheet. We don't want that exact curve. So what we do is just draw it 0, and minus 2, 21 is maximum point. You know minus 2, 21 is in the second quadrant. So second quadrant we have a point. Let this point be minus 2, 21. This is the maximum point. And 2 minus 11 is the minimum point, and you know 2 minus 11 is in the fourth quadrant. So let's take 2 minus 11, I point here. this is the minimum point. Now what you need to do is just draw the graph like this. A smooth curve we have to draw that makes the corresponding curve. Okay.